Hello, and welcome to my video presentation on my class project for USC's CSCI548 Knowledge Graph Embedding. The algorithm that we looked at is analogy, analogical inference for multi-relational embeddings. This is based on a paper and is also refactored from an original code base that appears on GitHub. After doing an overview of the algorithm itself, we are going to run through the Python notebook that's with this code base to see it run. Knowledge graphs typically contain only a small subset of all possible facts. This necessitates filling in the missing information, i.e. link prediction, knowledge graph completion. The task is to develop a model that can be used to predict new links or complete missing links in the given KG. Analogy is one such model. To train the model, we will input a set of triples of subject, relation, object, as well as a list of relations and entities, and some other model hyperparameters. After the model is trained, it will output the learned embeddings of the subjects, relations, and objects. Typical KG embedding models learn embeddings to optimize a score function, i.e. RESCAL. Each entity is represented by a vector embedding of m dimensions, each relation embedding represented by an m by m matrix, which can also be diagonalized, so it's only an m. Models utilize varying score and loss functions and training methods. Negative training samples need to be introduced. To calculate the benchmark metrics, we take a subject and relation from a triple in the test dataset. We score all entities against test subject and test relation, then rank the entities by score using the model's score function and learned embeddings. We do the same reversing subject and object. We can then calculate the mean reciprocal rank and the hits at k, which is the percentage of correct answers in top k rankings. The approach of analogy is to provide a framework for analogical inference. Analogical inference is particularly desirable in a KG model. The difference between analogy and previous models is that analogy adds a normality and commutativity constraint to the objective function. This allows it to better model relationships such as man is to king as woman is to queen, which are analogies. Analogy performed well versus other models. Analogy represents state-of-the-art performance. Further hyperparameter tuning may yield better results. We are now going to move on and look at how the Python notebook works for this codebase. Hello, and welcome to a demonstration of the Jupyter Notebook for the Analogy Codebase Refactoring Project for CSCI548 at USC. This first cell just sets up the imports, as well as hard-coding some of the input file parameters, model file parameters, relations, entities, and output file name. Next, we are going to read the data set in. Minimally, this must be the trained data, but optionally can also contain validation and whole text data, where the whole text data is used for filtered evaluation in the evaluator. We also need the relations and entities. Now that we're done loading the data, we need to learn the embeddings. This can take several minutes to 15 minutes per epoch, depending on the hyperparameters. Below we'll use some shortened hyperparameters, so we'll only use 5 epochs and 40 dimensions. Now it's working on training the first epoch. I'm going to come back in a minute when it's done and we'll continue. Okay, I'm back and we've finished training in 5 epochs. Now, optionally, we can save the model. This is desirable because you might want to use the model later and not want to have to retrain all the data. Some of these training runs can take 2 to 5 days, depending on your hyperparameters. So now we've saved the model. So now we're going to load the model, which is also optional, but we'll need a model to do other calculations. So we're actually going to load it into a new variable here. Next, we're going to use some test data. So we're going to add some test subjects, some test relations, and some test objects. And then we're going to print those embeddings for the subject, relation, and object. Here you can see the embeddings. For example, this first embedding, the thing to notice is that these embeddings are 20. There's 20 items in this vector, and that's because we have 20 as our dimension. Next, we're going to run the scoring matrix for the test data. The scoring matrix is actually going to run the subject and the relation that we input against all the other entities, and in this case 14,951, come up with a very large vector. And these vectors are the scores for this subject, relation, and object. So as you can see here, this is a 0.88 score. It's actually pretty good. Next, we're just going to print out some evaluation metrics for the trained model. We're actually going to use the whole text file so we can actually see the filtered output. Because we're using the whole text file, this will take a minute, and I'm going to put this on pause while it's loading the file. Okay, I'm back and our model is done evaluating itself. And as you can see here are our evaluation metrics. Hits, raw and filter, or MRR. The results are terrible because we didn't do very much training. But hopefully you can run the model on your own and come up with much better results. Thank you for watching my video.